Welcome back to pre-algebra. So far, we've mostly dealt with whole numbers, counting things like 1, 2, 3 apples. But the real world isn't always whole. What happens when you have half an apple, or $2.50 in change? In this video, we are exploring the math of parts of a whole. We have two main languages for describing these parts: fractions and decimals. They look different, but they usually talk about the exact same thing. Let's dive in. Equivalent fractions. This is the most important concept in the entire video. It means that different fractions can represent the exact same amount. Think of a pizza. If I cut it right down the middle and give you one piece, you have 1/2 of the pizza. Now imagine that same pizza, but instead of one cut, I cut it twice to make 4 equal slices. If I give you 2 of those slices, how much do you have? You have 2/4 of the pizza. But look at the two pizzas. The amount of red shaded area is exactly the same. We get equivalent fractions by multiplying or dividing the numerator, top number, and the denominator, bottom number, by the exact same number. Multiplying by 2/2, or 3/3, or 4/4 is just like multiplying by 1. You're not changing the value, just how it looks. Next up, simplifying fractions. This is the opposite of what we just did. Instead of making the numbers bigger, we want to shrink them down to their simplest form, the version with the smallest possible numerator and denominator. Here we have 16 out of 24 squares shaded. It's correct, but it's messy. To simplify, we need to group these small squares into larger blocks. Since 8 goes into both numbers, we divided both the top and bottom by 8. The largest number that fits into both. Let's group our squares into batches of 8. When we group them by 8, we see we have 2 large groups shaded out of 3 total large groups. And just like that, 16/24 becomes 2/3. That is the simplest, cleanest way to write this fraction. Let's try a real challenge. Imagine you have 1/2 of a cake, and you want to combine it with 1/3 of a cake. Look at these two slices. They are different sizes. We can't just add the numerators and say 1 + 1 is 2. That would be like adding apples and oranges. To add them, we need the pieces to be the exact same size. We need a common denominator. For 2 and 3, the smallest number they both fit into is 6. So we need to re-slice the pie. We're going to transform the 1/2 into 3/6 and the 1/3 into 2/6. But how do we actually calculate that change? We know our target denominator is 6 because that's the smallest number 2 and 3 both fit into. To get there, we have to change the fractions. For 1/2, we multiply the top and bottom by 3. So 1/2 becomes 3/6. For 1/3, we do the same logic. 3 times what is 6? 2. So we multiply the top and bottom by 2. This gives us 2/6. Now look at that. Both fractions are 6. The pieces are finally the same size. We just add the numerators. 3 slices plus 2 slices equals 5 slices. The denominator stays 6 because the slice size didn't change. Now, what if we want to subtract instead of add? Here is the good news. The process is identical. We still need a common denominator. We still change 1/2 to 3/6 and 1/3 to 2/6. The setup does not change. Here is the only difference. Instead of adding the tops, we subtract them. 3 slices take away 2 slices, leaves us with 1 slice. And just like before, the denominator stays 6 because the slice size didn't change. So 1/2 minus 1/3 is 1/6. Match the bottoms, subtract the tops. Simple. So, here is the golden rule for adding or subtracting fractions. You can't add or subtract them until they speak the same language. First, find a common denominator to match the bottoms. Once they match, the hard work is done. Just add or subtract the numerators. Keep the denominator exactly the same, and you've got your answer. Multiplying and dividing. And here's a surprise, these are actually much easier than adding, because you can forget about finding a common denominator. The secret is language. When you see a multiplication sign between two fractions, think of the word of. 1/2 times 1/3 really asks, what is 1/2 of 1/3? Here's a square representing one whole. First, we slice it into thirds and highlight the yellow strip, which is our 1/3. Then, the question asks for 1/2 of that third. So we cut the whole shape in half horizontally and shade the top part blue. The answer is the overlap, the place where the blue and yellow create green. The grid shows 6 total pieces, and one of them is green. So the answer is 1/6. This lets you see the shortcut clearly. Multiply the tops and multiply the bottoms. 1 times 1 is 1, and 2 times 3 is 6. Now let's look at division. 1/2 divided by 1/4. It looks scary, but it's just asking how many 1/4ths fit inside 1/2. Here is our space, 1/2. How many quarter-sized pieces can we pack inside? Exactly 2 of them fit, so the answer is 2. To solve this without drawing, we use the shortcut keep, change, flip. Keep the first fraction, change division to multiplication, and flip the second fraction, and the math confirms the result is 2. Decimals. Sometimes a whole number isn't precise enough. Decimals allow us to describe the pieces of the whole with perfect accuracy. You know ones, tens, and hundreds. Every time we move right, the value gets 10 times smaller. What happens when we cross the decimal point to the right of the ones place? We get tenths. It means 2 out of 10 parts of a whole. If we add another digit, like 345.27, we move to the hundredths place. So decimals help us describe little pieces of a whole with ease. Once you move to the right of the decimal point, you enter the world of tenths, hundredths, and smaller parts, making numbers clearer and more exact. Imagine for a second that we are in a language class. Hi and hola are completely different words, yet they mean the exact same greeting. Math works the same way. 1/2 and 0.5 look different, but they represent the exact same value. We aren't changing the numbers. We are just translating between two different languages. So, let's learn how to become a translator. First, decimal to fraction. To turn this directly into a fraction, look at the last digit. The 5 is in the hundredths place. This tells us the denominator is 100. We simply take the entire number, 275, and write it over 100. We now have 275 hundredths. Now we simplify. Both numbers are divisible by 25. Think of quarters. There are 4 quarters in a dollar, so there are 11 quarters in $2.75. So the top becomes 11 and the bottom becomes 4. We get 11 fourths. Now let's go the other way. Let's turn 11 fourths back into a decimal. Remember, the fraction bar is just a division sign. 411 literally means 11 divided by 4. So we set up long division. Does 4 fit into 1? No. Does 4 fit into 11? Yes, it fits 2 times. 4 times 2 is 8. Subtract that from 11 and we have a remainder of 3. Now 4 cannot fit into 3. In the past, we'd stop here, but with decimals, we can keep going. We place a decimal point after the 11, and this is critical. We put another decimal point directly above it in our answer. Now we add a 0 to bring down. Now we ask, how many times does 4 go into 30? 7 times. 4 times 7 is 28. Subtract that from 30, and we are left with 2. We still have a remainder, so we add one more 0. Bring it down to make 20. How many times does 4 go into 20? Exactly 5 times. 4 times 5 is 20. The remainder is 0, so we are finished. The answer is 2.75. We have successfully translated the number back. Finally, operations with decimals. The good news is you already know how to do this. It's just like regular addition, subtraction, and multiplication with one extra rule for the decimal point. For addition and subtraction, the rule is line up the dots. If you don't line up the decimal points, you're adding tenths to hundredths, which doesn't work. Once lined up, we can add and subtract. The result of our example is 16.25. For multiplication, the rule is simple. Ignore the dots until the very end. Pretend they aren't even there. Just treat the numbers like standard whole numbers. We aren't multiplying 2.4 times 0.8. We are multiplying 24 times 8. 8 times 4 is 32. Write the 2 and carry the 3. Next, 8 times 2 is 16. Add the 3 we carried, and we get 19. So our temporary answer is 192. Now we have to pay the price. We ignored the decimals earlier, so we have to put them back. Count the total decimal places in the original problem. 2.4 has 1 place, and 0.8 has 1 place, giving 2 places total. So we move the decimal point in our answer 2 spots from the right. 1 hop, 2 hops. The final answer is 1.92. And this makes sense because 2.4 is close to 2 and 0.8 is close to 1, so our answer should be close to 2. And finally, division. This is the one that trips people up. Let's try 2.4 divided by 0.4. The golden rule of division is the outside number must be a whole number. We don't want to think about the 0.4 times table, we want the 4 times table. So we move the outside decimal 1 spot to the right to make it 4. But to keep the answer correct, whatever you do to the outside, you must do to the inside. So 2.4 becomes 24. Now it's just 24 divided by 4. The answer is 6. Let's look at a harder one. 0.15 divided by 0.03. We move the outside decimal 2 steps to the right to create the whole number 3. Since we move the outside dot 2 steps, we move the inside dot 2 steps, so 0.15 becomes 15. Now the problem is 15 divided by 3, and the answer is 5. One last scenario. What if the inside runs out of room? Consider 12 divided by 0.6. 12 has an invisible decimal point at the end. We move the outside decimal 1 hop right to make 6. We also move the inside decimal 1 hop right, and since there's no digit there, a 0 pops in to fill the gap. This transforms our messy problem into a clean one, 120 divided by 6. Since we mastered whole number division in the last video, this is easy for us. The answer is 20. Fractions and decimals are just 2 different ways to talk about parts of a whole. Fractions talk about slicing things into equal pieces. Decimals talk about zooming in on a base 10 number line. Keep practicing, and I'll see you in the next one.